Okay. In the previous lecture, we talked about this example, and here. In this example, we are gonna find the inverse of a function. To find the inverse of a function, we can follow these steps. I'm gonna write down the steps here, okay, for finding inverse of a function. We say, first, we write down f of x to be y. We let f of x to be y. That means we are going to equal f of x to y. This is the first step. And in the second step, what we do, write down the function for x. Write down the function for x. That means we are going to put x alone in one side of the equality and all the others to the other side of the equality. And in step 3, interchange x and y. That means we change each x to y and each y to x. We just interchange them. We just follow these 3 steps. The function that we get as, let's say, write down step 4. The function we get is f inverse. The function of x, which we obtain is the inverse of f, means f inverse of x. Okay, here we just follow these 4 steps for finding inverse of any function. Here we have given a function. The function is f of x is 4x minus 1. We should find the inverse for this function. We just follow the steps that I have written down there. The first step, we say we equal y to f of x. That means we replace f of x by y. We replace f of x by y. So here, I'm gonna solve it here. The function is f of x equals, let's write down the function, 4x minus 1. We have this function. To find the inverse for this function, means to find f inverse of x. What we do? In the first step, we are going to say f of x to be y. That means you replace f of x by y. So in step 1, you say y equals 4x minus 1. This is the first step. In the second step, we are going to write down the function for x. Here, the function is for y. We say y equals to a function. Okay? If we write down the function for x, that means we should leave x alone in the left-hand side and putting all the others to the left. Okay? Here, we leave this. We leave x in the right and putting all the others to the left. Let's see. Here, first, we should move this -1 to left. We should move that -1 to left. We get y plus 1. It's -1. When you move it to the left, it becomes plus 1. Equals 4x. And here, how to remove this 4 here? By dividing both sides by 4. We must get only x without coefficients. So here, we divide both sides by 4. What we get? In the left-hand side, we get y plus 1 dividing by 4 equals x. Okay, it's step 2. This is step 2. In step 3, we interchange x and y. We replace x by y and y by x. In step 3, if we interchange x and y here, what we get? we get x plus 1 over 4 equals y, is it? This function that we get is f inverse. So in step 4, we say f inverse of x equals x plus 1 over 4. This is the inverse of that function. It should be here. You even can leave this y plus 1 over 4, the function. From that, you can just write down the result. But here, it's better to interchange x and y. Here, it's written f inverse of y. But you should find f inverse of x. Okay. Well, let's follow the way what's written down here. That means we don't need to interchange x and y. We just write down step 4. Okay, the last step. That means here we are not gonna interchange these two. So you say f inverse of y equals y plus 1 over 4. Yeah, we just leave. We just skip step 3 and step 3. So now we have only 3 steps. We just follow the method which you see. Okay. To find the inverse of a function, to find the inverse of a function as to find the inverse, we just follow these 3 steps. First, we say f of x to be y, then write down the function for x, okay? And the function that we get is f inverse of y. Let's take another example, okay? Let's take another. If there is anyone here, let me check. No, there is no in the exercises. Okay, here there are. And says find the inverse of each of the following function. Let's solve this one. Let's find the inverse of this function. What do you say? What do you do first? We just replace f of x by y. That means you say y equals, it's for the first one. I mean for B. You say y equals 3 plus 1 over x. Okay, that's 3 plus 1 over x. We just replace f of x by y in the first step. And then what we do, we're going to write down the function for x. We are going to write down the function for x. First, we move this to here. Okay, we get y minus 3 equals 1 over x. How to get x here? By inverting both sides. It's of 1. How to get x? In the right hand side, you have 1 over x. And how to get x? We say 1 over y minus 3 equals x over 1. That's 1 over x. It becomes x over 1. So here, this denominator could be notched. This function that you get is the inverse of the given function. So you say if inverse of y equals 1 over y minus 3, that's all. This is how to find inverse of a function. Okay? Take a look. تنهاو سيستفيد سرتالين y x and f of x. دوات النقشة بو x نسي. دوات الكدس بانكو 2x على f inverse. Okay? So now we have composition. Composition of functions. Just suppose g is a function from x to y and f is a function from y to z. Yeah, you have this x, this y, and this is z. This x, this is y, and this is z. You say g is a function from x to y, and then f is a function from y to z. From y to z. If we want to find a function from x to z, We say it is G circle F. G circle F of X is from X to Z. G circle F circle G, or G circle F. It also could be written like this: F of G of X. Here we are going to replace each X in F by G of X. Let's take an example. That's it. Here we have F of X to be this function, G of X to be this, and H of X to be this, W is this. It says find F of X, where F of X to be G of H of W of X. You should find this. But before we find composition of three functions, let's do for two functions. Let's say G of X and H of X. We say G circle H of X, it equals G of H of X. كاتبون G circle نقشة كتير وهذا G of أو نقشة. أوكي نقشة كم أو نقشة دو. ليرة G of X شيء أخوي. G of X. G of X رقي X. As you see here. G of X ليرة رقي X. H of X شيء. Sin X. Let's write down them both. To find G circle H of X, that means we should find G of H of X. Here, G of X is the square root of X. How about G of 2? And G of 2 شنو؟ رقي دنيا. لجي X دنيا داناني. أي G ناقص بابلين G شوار شنو؟ دو. ونيا هذا رقي شوار وكذا دو. أي باشا G دو X شيء. لجي X دانين دو X. كذا شيء. رقي دو X. ونيا أو إذا G كم هي؟ G H of X هي. H of X شيء. Sin X. كواتا ليرة G of sin X. How about this one? What's G of sin X here? We just replace X by sin X and you get square root of sin X. So how about H of G of X? How about this one? Here we found G circle H and here H circle G. How about this one? It equals H of G of X. What's G of X? G of X is the square root of X. This is G of X. And this is H of X. This H of X is sin X. How about H of 2? Sin 2, is it? How about H of 4? It's sin 4. How about H of, let's say, X squared? Sin X squared, is it? We just replace by the one what's written here. We replace X by the term which is written here. And here we have H of G of X. What's G of X? It's square root of X. We get H of square root of X. And H is sin X. So we get sin square root of X. We just replace X by square root of X in the function H. Okay. So it's how to find the composition of two functions. Here we have given three functions. And you should find their composition. It says G of X is square root of X, H of X is sin X, and W of X is 2X. And you should find G of H of W of X. Let's find it. To find this, we say f of X equals, it's given that. We should find this one. F of X equals G of h of w of x. First, we start from the last function. We just replace it by its terms. Okay. So what's w of x? It's 2x. So you replace w of x by 2x, and we get g of h of 2x. We just replace w of x by the function. تنها لجي w of x مدانا ونخشى خو مدانا. And then what's h of 2x? We replace x by 2x in the function h. This is h of x. How about h of 2x? We replace x by 2x, and we get sine 2x. It equals g of sine 2x. G is the square root of x. How about g of something? Means it's the square root of that thing. Okay. We say g of x is the square root of x. So how about g of sine 2x as the square root of sine 2x? We just replace x in function g by the angle, by sine 2x. And we get the square root of sine 2x. So this is f of x, which is required to find. It's given that here actually, but you should find it from those three functions. So this equals to what? If we have given us a circle, it is g circle, h circle, w of x. If you write down this in this form, it becomes it. Okay, it's g of h of w of x. Then we start from the last function. We just write down the function as we did here. And then we're going to find h of 2x. H of x is sine x. So how about h of 2x is sine 2x. Then g of sine 2x. G of x is square root of x. How about g of sine 2x? We just replace x by sine 2x in the function of g. Now we have an example here. It says g is a relation. G is a relation from x to y. From x to y. It's 1a, 2a, 3c. As you see, 1a, 2a, 3c. This is function g. And also, f is a function from y to z. This is y and that's z. Look, g is from x to y, and f is from y to z. This is g, this is f. F is defined by ay, bx, cz. That means between a to y, b to x, c to z. This is the functions together. So how about f circle g from these two functions, from the functions f and g? So f circle g is f of g of x. Look, from 1 we go to a, then from a we go to y. That means f circle g of 1 is y. Okay, from 1 we go to a, then to y. Look here, what are the images of elements x in z? How do you go? You go from here. It goes to here. Is it? And then this goes to there. That means image of 1 is y in the composition function. That means f circle g for 1 equals y. Okay? How about 2? 2 goes to a. A goes to y. That means f circle g of 2 equals y. It's also equal 1. How about 3? 3 goes to C, and then C goes to Z. So if circle G of 3 equals Z. So what are the relations in F circle G? You say F circle G of X equals to what? Equals 1 and Y. Is it? 1 goes to Y. About 2? 2 and Y. Then 3 and Z. We have only these 3 elements in the relation. Okay? And this is the diagram. 1 goes to Y, 2 goes to Y, and 3 goes to Z. This is for F circle G. F circle G is a function from X to Z. As you see here, Y is skipped. It's only we have X and Z. We only have X and Z. So the composition of functions of F and G is this function. That's it. That's written here actually. We can get it from these 2 functions. And from the sets, we also can get that. Look, 1 goes to A, then A goes to Y. Okay? It means we have 1 and Y. 2 goes to A, then A goes to Y. That means 2 related to Y also. For 3, 3 goes to C, and C goes to Z. That means 3 related to Z. Okay, we have only these 3 elements in F circle G. Here we have given 2 functions, and we should find F circle G and G circle F. F circle G and G circle F. Let's find them. For F circle G, say for F circle G equals F of G of X. So it's G of X. G of X is X to the power 4. And F of X is logarithm of X to the base 3. Okay? And so we say it equals F of what? X to the power 4. We just replace G by the function. G of X is a function of X to the power 4. And then we are going to find F of X to the power 4. Later, سرتا وتوان نقشي كوتا داني نو نقشي كوتا چيا x2 شوار G x2 شوار داني انجلي if x2 شوار داني ادوسي واتا لجي هل x ناو نقشي if x2 شوار داني اما نقشي if اقل لجي x2 شوار داني چي ما دزك equals this is F circle G. How about G circle F? You say G circle F equals G of F of X. So what's F of X? Yeah, we replace first F of X by the function. It equals log G of logarithm X to the base 3. What's G of logarithm 3 to the logarithm X to the base 3? We replace each X in function G by this function. How many X do you have in function G? You have only 1 X, which is to the power 4. That means we just replace X by this to the power 4. We get logarithm X to the base 3 to the power 4. That's all. As you see here, G circle F doesn't equal to F circle G. G circle F doesn't equal to F circle G. So these 2 are not equal. So that's written. لو تيجن we now have a function f from z to z, where g and g also from z to z by the rules. F of a equals 7a, and g of a equals a mod 5 for all integers a. Do you know what's mod? You should know that because it's used in computer programming. Okay. When we say a number mod, let's say b, let's say a mod b is the remainder equals to the remainder. For example, we say 3 mod 2 it equals 1 because here we just get 1 as the remainder. For example, 5 mod, let's say 3. What's this? It's 2, is it? So 7 mod, let's say 4. It equals what? 7 divided by 4. What's left? 3. Okay. تنها أوي كأمانته وتوان. دعوة شكل أوي كمايا ورق. So how about let's say 3 mod 4. 3 can't be divided by 4. So you just write down 3 yourself. Okay. That's it. Now we should find this. It says f is f of a equals 7 times 8. That means, let's say f of 2 is 7 times 2. F of 3, 7 times 3. It's like function f is 7 times 8. And function g is a mod 5. We just find mod of the number of 5. Let's say here we have g circle f for 0. It equals g of f of 0. So how about f of 0? This is f of a. This is the function of f. If you find f of 0 here, we get 7 times 0. What's 0? G of 0. What's g of 0? 0 mod 5 is 0. Okay? 0 mod 5 is 0. Okay? How about g circle f of 1? It equals g of f of 1. f يكشيها حوكة رديك ونيا شو قلنا شيء f على حوكة رديش معنا. So you get g of 7. How about g of 7? 7 divided by 5. What's the remainder here? 2, yeah. How about g circle f of 2? It's g of f of 2. What's g of f of 2? It's 14. G of 14. 14 mod 5 is 4. And for 3, it's equals to g of f of 3. What's f of 3? It's 21. It's g of 21. It equals 1. Put this. Mod ليه ما الكمبيوتر زيادة بكارهم مثلا ما وكيتي كذا كجمالي داوجي مثل جمالي كات شي ما يونا بونمونا كاتي أنا سي مودي دو شن يمين دو سي داوجي دو كين شن يمين دو يه ونيا زانك بوين بينش بلان بانتيجر وشي يمين كاتي كداوجي كين أبي انتيجر ما نسكت لدو انتيجر كت شي مان شي يمين دو نيو عفو نيو كشان يكلير شكل يجلس دو كات وأتا يكمل دو سه دابش دوبكا چنج ما يتعود دزكه وچني من دو چني من دو يا ونيا كواتا ما كات سنة يا بونمون حفا مودي باولين هشت بانو حفا مودينو اي باشا بو كاتت چوار ده دابشی پنج دوتیه چنی منیتو چنی امنیتو نه چنی امنیتو وایا okay you have 14 dividing by 5 okay 14 divided by 5 we cannot divide 1 by 5 so we take 14 divided by 5 is 2 2 times 5 is 10 if we subtract 10 from 14 it's 4 can we divide this by that no what's this number that's mod okay it's the remainder okay and here we have g circle f of 4 it's g of f of 4 what's the f of 4 it's 28 4 times 7 it's g of 27 how about mod of 27 I mean 5 is 2 we can divide 27 by 5 and it remain 2 that's for this example. Do you have any question about this example? Okay, that's so easy. And here you have these examples for your students. Now we have the last part of chapter 1, which is sequence recurrence relations and recursive algorithm. This recursive algorithm is the structure of programming, the structure of the computer programming for the recurrence function. ليرة إنك همانا recursive algorithm algorithm that يبو شكاري بساري يعني بس ما الستركتوري programming أكيد شلون programming هي بون بس الكمبيوتر. Okay بس يا Here, first we have sequence. We say a sequence is a function whose domain is either all the integers between two given integers or all the integers greater than or equal to a given integer. Generally, we say the domain of a sequence is the set of integer numbers. Okay, we work on the integer numbers, and here we say in the sequence denoted by am plus 1, am plus 2 up to an. Each of these is a term. Each of these is a term of the sequence. Here, as it's written here, each of these is called term. K, which is this number, these are index or subscripts. These are index or subscript. And am, which is the first term, is called initial term. It's called initial term. And an, which is the last one, is called final term. Look, initial term is the first term, and final term is the last one. Here, we can express a sequence by a formula. We can express by a formula. We say an explicit formula for general formula for a sequence is a rule that shows how the values ak depend on k. Here, as a function that you can generate all the terms for the sequence. As you see here, this is the formula. This is the general form of the sequence. You have an equals 1 over n. Here you can generate all the terms for the sequence by this formula. What's A1? Here, A1 equals 1 over 1. Here, we just replace n by 1. How about A2? We replace n by 2, 1 over 2. How about A3? 1 over 3. A4, 1 over 4. A5, 1 over 5. Look, this is the first term. This is the second term. Third, fourth, 5, and so on. What's the first term? It's 1. How about the second one? It's a half. And the third one? It's like that. This is, look, this is the formula that we can generate all terms of the sequence. Look, the sequence is beginning with A1. A1 is 1 because here we replace n by 1 and we get 1 over 1, which is 1. If we replace n, if this is 1, so we must replace this by 1. If this is 2, we replace this by 2 also. If this is 3, we replace this by 3. Okay, that's so, and so on. This A1, A2, A3, and A4, so on. It's 1, 1, 1.5, 1/3, 1/4, and so on. That's what you found. When you have recurrence relations, it says a recurrence relations or a recurrence for a sequence AN is an equation that expresses AN in terms of one or more of the previous terms. That means here a recurrence relation is a sequence that each term depends on the previous terms. May depends on the previous one, or may it depends on 2 or more terms before it. Here we have I0, A1, A2, and so up to AN minus 1. Here for n to be greater than or equal to n0, where n0 is a non-negative integer. That means the indices or the subscripts must always be 0 or positive. They don't have to be negative. Okay? These, I mean, here. AM plus 1, AM plus 2, up to AM. These all must be from 0 to infinity. They don't have to be negative. Okay, we can't say a negative 1. We cannot say that. We can't say this. But we can say A0, A1, A2, and so on. Here we say a sequence is called solution for a recurrence relation. Here recurrence relation is the formula. Recurrence relation is the formula. We say a sequence is the numerate form. Okay, here this is the sequence, but this one is the recurrence relation. Okay, the formula is the recurrence relation, but the numerate one is the sequence. We say a sequence is called a solution for a recurrence relation if its terms satisfy the recurrence relation. If all of these terms satisfy this, means this is the solution for that recurrence relation. Look, 1 equals 1 over 1. 1.5 equals 1 over 2. Okay, A2 equals 1 over 2. 1, 3. Yeah, A3 equals 1 over 3, and so on. So these all are satisfying the terms of the recurrence relation. Here, initial condition or conditions. See, the information called the initial condition or conditions for the recurrence must be provided to give enough information about the equation to get started. ليه على شيء؟ على أبي أنا معلومات كده أبي بقول كيف دستبي شو دستبي واتبون منا أبيش تستر تاعك أنا أبي درابي شون تير مكان بدوسينه لأن كم أبي فورمولا كم بدرابي أجر دام على بكس كم سيكون بدوسينه فورمولا كم بيجت كأشياء recurrence relation كيا هو first term مش معناه بيقول first term أجر هاتو دوم تيرم اعتمادي كده ستنها يا كم تيرم أبي كم تيرم ما بيجت أجر هاتو ترمك ما هبو هر ترمي اعتمادي كده سدواني بيشوي أو كاتب ترمي كم دوم ما بيجت بمشي وهذا شنو بيس بيه أبي ما بيجت. Here we take examples later on. Okay. For the simple recurrence relation, you say a simple recurrence relation is a recurrence relation that every term depends on only the previous term, not the other terms, only the previous term. For example, if we have A0, A1, A2, A3, A4. Here, A1 depends on only A0. A2 depends on only A1. A3 depends on A2. A4 depends on A3. But we have some sequences that could depend on more than one term before it. Here it's A0, A1, A2, A3, A4, A5, and so on. Here we say A2 depends on both A0 and A1. A3 depends on A2 and A1. وهذا الترمي اعتماد كاسة دواني بيشكوي. دواني راسه هو بيشكوي. أكلي أول شيء. أكلي اعتماد كاسة سياني بيشكوي. أجر اعتماد كاسة دواني بيشكوي. كاتبه يكم ترم دوم ترم أم بيبدريت. أبي بيمان بدريت. يكم ترم دوم ترم. أجر اعتماد كاسة يقدر بيشكوي. تنها يكتر ما بيجي. أو كذا. بودس بي. So that's. Here we say simple recurrence relation is a recurrence relation that every term depends on only the previous term. Here we have an example. It says an equals an minus 1 plus 5. This is a recurrence relation. Write down the sequence. Here it says A1 is 3. Look, the initial condition is given. A1 is 3. So A1 is 3. So the sequence is 3. Then what's the second term? We say each term depends on the previous one. How about A2? We say A2 equals A2 minus 1 plus 5. We just replace n by 2 to get 2. And so what you obtain A2 equals A1 plus 5. A1 is given, which is 3. We get 3 plus 5, which is 8. The second term is 8. How about the third term? For A3, we say it equals, we replace each n here by 3. A3 equals A3 minus 1 plus 5. How about A3 minus 1? It's A2 plus 5. What's A2? A2 is 8 plus 5 is 13. And then, how about the next term? Look, each term is the immediate term, the immediate previous term plus 5. Each term is the immediate term, the immediate previous term plus 5. Look, 13 plus 5 is 18. Plus 5 is 23. Plus 5 is If you know the terms, how do they change? You just can write down the terms. سلك الليرة على هالترميك أكاد شيء ترمي بيش خوي زائد بينش. وايا هالترميك أكاد ترمي بيش خوي زائد بينش. ترمي كمان بيدراو. يا كم تشيا سير. كا ترمي دو مكاتب شيء. ترمي بيش خوي زائد سير. زائد بينش. سير بينش هشت. أي ترمي سيم شيء شيء. يا ترمي دوام زائد بينش. هش زائد بينش. بهما شو بدل. هذا ما اشتري. اوكي ليرة كاتيري اي ان واي ان ناقص وتاغ ما الدبيت اما النوي اما هش بيت اما حوته اما بينس بيت اما تشوال ابي اني شرط سوسي قلتم شي اقل اعتمادي كده تنهاسر يكتيرم اي بيت بدري الليرة اعتمادي اسر شن يك داني بس داني بيشكل اقل اعتمادي اسر دواني بيشكل ابي دواني بيو بدري اي اوقات ايكو ايدو يعني اي نوتو ايكو بيد تدواني سرتا باشا بيدري اني شرغه بيدري لم اكزامبل اي وندراوا ام فانكشن اشتراوا اتواني اواني كبدو استوا تا hello here we have some more examples it will be much good. Okay, let's take a break now. There we start. Here we have another example. It says find the nth terms of a sequence. In the example, we have given an be a sequence which satisfies this reconciliation. An equals an minus 1 plus 3. This an minus 1 plus 3. It's given that a naught is 2. And we should find A1, A2, and A3. What are A1, A2, and A3? Okay. We have given this relation. The relation is, the recurrence relation is an equals an minus 1 plus 3. That means each term depends on the previous one. Or you can say each term is the previous term plus 3. This is the recurrence relation. We have given a naught, which is 2. And we should find A1, A2, and A3. A naught is 2. How about A1? A1 is an minus 1, which is A naught, plus 3. Each term depends on the previous one. And the recurrence relation is each term is the previous one plus 3. So here I naught is 2. I naught is 2. How about A1? A1 is A naught plus 3. And A2. A2 is A1 plus 3. A3 is A2 plus 3. And so on. Okay. Here, what's A1? A1 is A naught plus 3. But A naught is given, which is 2. So it's 2 plus 3 is 5. Is it? And then for A2, A2 is A1 plus 3. A1 is 5 plus 3 is 8. Then A3 is A2 plus 3. A2 is 3, is 8. 8 plus 3 is 11. So these are A1, A2, and A3. That's it. Each theorem depends on the previous one. And you say the nth theorem is the n minus 1 theorem plus 3. So here A1 is A naught plus 3. A2 is A1 plus 3. A3 is A2 plus 3. So here to find A3, we must have A2, then we can find A3. For A2, we must have A1, then we can find A2. For A1, we must have A naught, then we can find A2 is plus 3. A1 is A0 plus 3. A0 is given, which is 2. We say it is 2 plus 3, and it equals 5, and so on for others. Here, the recurrence relation is given, which is 3, which an equals an minus 1 plus 3. That means the difference of each two successive terms is 3. So here, we have given the sequence, and we should find the relation. We should find the relation, the recurrence relation. To find the recurrence relation, what we do? We should first find the pattern. Yeah, it's 3, 9, 27, 81, 243, and so on. Look, this is 3 to the power 1. This is 3 to the power 2. This is 3 to the power 3. This 3 to the power 4, and so on. Okay, that means here we say A1 equals 3 to the power 1. A2 equals 3 to the power 2. A3 equals 3 to the power 3. A4 equals 3 to the power 4, and so on. Okay, that means here we have 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, and so on. And then we say A1 is 3 to the power 1. A2 is 3 to the power 2. A3 is 3 to the power 3. A4 is 3 to the power 4. That means AN equals 3 to the power n. Is it? AN is 3 to the power n. This is the recurrence relation. This is our recurrence relation. This is A1, this is A2. Second, index كانت A1 720. كانت A2 720. كانت AC 720. كانت AN كانت 720. Okay? So this is the recurrence relation for the given sequence. Here we have an example. We have given A1, sorry, A0, which is 1. And we should find a few sequences. It says AN equals 1 plus 2 AN minus 1. As you see, AN depends on AN minus 1. That means each term depends on the previous one. How? It equals 1 plus 2 times the previous one. 1 plus 2 times the previous one. Here, A1 is A0 is given, and A1 equals 1 plus 2 times A0. Is it? Regarding to this recurrence relation, layer recurrence relation كان بيدرا AN كاتي يك زائد 2 AN minus 1. That means each one depends on the previous one by multiplying by 2 and then adding 1. The A2 equals 1 plus 2 A1. A3 equals 1 plus 2 A3. Sorry, A2. A4 equals 1 plus 2 A3, and so on. It's like that. To find the few terms of the sequence, we say A1 equals to what? Sorry. A1 equals 2 times A0 plus 1. 2 times A0 plus 1. A0 is given. It's 1. It's 1. This is the initial condition. This is A1. A0. A0 is given. 2 times A0 is 2. Plus 1 is 3. This A1. How about A2? A2 is 2 times A1 plus 1. 2 times A1. A1, we found that it's 3. 2 times 3 is 6 plus 1 7 A3 equal سيكل شلون هالإليمنت احتمال يصير بيشوي شلون قلنا أي نوت دراو أي وانا كاتشي دو كارت أي نوت زائد أي سي أي دو كاتشي دو كارت أي 1 زائد أي سي كاتشي دو كارت أي 2 زائد هم بهالإليمنت دو ضربي بيشوي كين زائد okay here we have given a note to find a1 what we say it is 1 plus 2 times a note is 1 so 2 times 1 is 2 plus 1 is 3 now we found a1 is 3 2 times 3 is 6 plus 1 is 7 how about a3 it is 2 times a2 we found a2 is 7 2 times 7 is 14 plus 1 15 a4 equals 2 times a3 we found a3 is 15 2 times 15 is 30 plus 1 31 and so these are the features of the sequence so the sequence could be written as 1 3 7 this a0 a1 a2 and so 15 31 63 and so these are the features of the sequence. You always should use the recurrence relation for finding the terms. Okay, but here the initial condition must be given, and then you can find it. Here the initial condition is A0 is given, which is the first term. The first term is given, which is 1. How about the second term? The second term is 2 times first term plus 1. And to find the third term, we say 2 times second term plus 1, and so on. And here we have given a recurrence relation, which every element depends on 2 successive previous terms. 2 successive previous terms. That means here we must have A0 and A1. These are the initial conditions. As I said, if each term depends on 2 previous terms, so we must have 2 terms. So in the example, 2 terms must be given, 2 first terms. It's given A0 and A1. A0 is 1 and A1 is 2. This is 1 and 2. How about the third term? The third term depends on these 2 terms. How? It's 3 times the sum of these 2 terms. 3 times the sum of these 2 terms. That means A2 equals 3 times A0 plus A1. Look, A2 depends on A0 and A1. How about A3? Depends on what? Depends on A1 and A2. That means 3 times A1 plus A2. A4 equals 3 times A2 plus A3. And so, okay. And here, how about A2? A2 equals to 3 times A0 plus A1. What's A0? That's given, which is 1. A1 is also given, which is 2. 1 plus 2 is 3. Times 3 is 9. So it's 9. And then, what's A1? A1 is given, which is 2. A2, we found that it's 9. 2 plus 9 is 11. Times 3 is 33. And then, for A4, we say it depends on A2 and A3. A2 is 9. A3 is 33. 9 plus 33 is 42. 42 times 3 and 42. And it's 26, sorry. So, these are the few terms of the sequence. Yeah, we just use the recurrence relation and the given information, which are the initial conditions. Here we have given two initial conditions because in the relation, in the recurrence relation, each term depends on the two successive previous terms. Here we have an application example. It says for a photo shoot, the staff at a company have been arranged such that there are 10 people in front. If this is the first row, these are the front ones. Here we have 10 people. Okay? In the front row. And each row has 7 more people than the row in front. That means in the second row, we have 17. Here we have 10 people. In the first row, in front, we have 10 people. In the row after, we have 17. How about the later one? The next one is we have 7 more from this one, which is 24. Is it? And then for this one, we have 7 more is 31, and so on. Okay? It says, write down the recurrence relation. That means you should write down the formula. The formula. Look, each of these, this depends on this one. This depends on this one. This depends. Second. روي دوم رجزي دوم اعتمادا سد ريزيكا ريزيكا شين تيا زايد حوتي والله إنك l'example كده اوكي ريزيكا شين تيا زايد حوتي ريزي بو ريزي سيم تشيبين أنا ريزي دوم شين تيا زايد حوتي بو ريزي شوارع أنا ريزي سيم شين تيا زايد حوتي. That means each term depends on the previous one. So what's the formula? The formula is the previous term plus 7. That means an equals an minus 1 plus 7. This is the formula. This is the recurrence relation. Okay? Do you know how do you find that? Okay. And then we should find the first 5 rows. Okay? A1 is given, which is 10. It's given. For the second one, A2 is A1 plus 7, which 10 plus 7 is 17. For A3 is A2 plus 7. A2 is 17, plus 7 is 24. Then for A4 is A3 plus 7. A3 is 24, plus 7 is 31. Then for A5 is A4 plus 7. A4 is given, we found that it's 31, plus 7 is 38. That's it. These are the first 5 rows. Okay. So in the example, we are asked to find the relation, the recurrence relation, and also first 5 rows. This is not given in the example. We should find this one, but we have given enough information to find that. It says the first row is 10, and the next row is there are 7 more people in it, and for next one 7 more. Okay, that means each row depends on the previous one by adding 7 to the previous one. Here we should find the recurrence relation and initial condition for this example, for this sequence. The sequence is given 1, 5, 17, 53, 161, 485, and so on. We have given this sequence. What should we find? we should find the initial condition. That means A1 or A0. We should find A0. And also the recurrence relation. What's AN? AN equals to what? So how about A0 equals? AN should be as a formula, but A0 must be a number. How to find this? What we do? We first should find the difference between these. If we couldn't find directly, like the previous one, we should find the difference. 5 minus 1 is 4. 17 minus 5 is 12. Look, this is 4. This is 12. This is 53 minus 17 is 36. And so, okay, as you see, it's 4 times 3 is 12. Times 3 is 36. And so that means we have multiplied by 3. Each term, and the difference by the factor is going by the factor 3. Look, this 4 times 3, we get this. Times 3, we get this. Times 3, and so we get that. So this is the difference. We first find the difference. How? We say AN plus 1 minus AN. We say 5 minus 1. 17 minus 5. 53 minus 17. 161 minus 53, and so we get this. So from this sequence that we get, which is the sequence of the difference, we see that the difference is going by factor 3. Each one multiplied by 3 to get the next one. And then the original one, this one, 5, 17, 53, and so on. This is not multiplied by 3. It's not going by the factor 3. Okay, but only the difference is going by the factor 3. You see, 1 times 3 is 3. 5 times 3 is 15. 17 times 3 is 51. Okay, here we have 1. This is the original sequence. This is the original sequence which is given. We say by comparing this, by comparing the original sequence with the difference as 4, 12, 36, 108, and so on. We say this is going by factor 3. That means we must multiply the terms by 3. We must multiply the previous terms by 3 because it's going by factor 3. Okay, so we say AN equals 3 AN minus 1. And then let's see what else do we have. What else do we have? Look, if this is 1, we say A1 equals 3 A0. A2 equals 3 A1. A3 equals 3 A2, and so on. Let's check in. اما دي فورمولا كادوسين شلون فورمولا كابدوسين ستة ديفرنس كان دوسينو زين بس فاكتوري روشتوا او فاكتوري كبير روشتوا ابي لك داني كلمه كذا ابي لك دان كذا ابي لك فورمولا كذا. Okay, so you have 3 AN minus 1, and we will find what else do we have. Okay, we say the first term is 1. The first term is 1. That means 3 times 1 to find the second term. 3 times 1 is 3. So what else do I add for the formula to get 5? 3 times 1 is 3 plus 2 to get the second term. Okay, we let A naught to be 1. This is the first term. For finding the second term, we multiply the first term by 3. That's the factor. Then what else should I add for the formula? I should add 2 also. Let us take a radical say. Okay, so it's 5. This is A1. And here we have 3 times A1. A1 is 5, which is 15. شنو يبغى زيادة بويك تيرمي دواتين دسكيت حفا كمان دسكيت ها شنو يبغى زيادة بويك حفا ما دسكيت pounds زائد plus 2 and then so it's 17. It's 17. It's A2. How about A3? A3 is 3 times A2. A2 is 17. It's 51. What should I add to get 53 plus 2? That means we must add 2 for each term. That means here we have 3an minus 1 plus 2. This is the formula. As you see here, an is 3 times n minus 1 plus 2. And the initial condition, I note, is 1, which is the first term. Always the first term is the initial condition. Okay, the first term is always the initial condition. What's the first term in the sequence which is given? It's 1. So it's A naught. That's the first term. And to find the formula, we first found the difference. And then from the difference, we see that it's going by factor 3. As that's going by factor 3, that means we must multiply the term in the formula by 3. We say an equals 3an minus 1. And then we found that we must add 2 for each term to get the next term. By multiplying by 3 and then adding 2, we get the next term, and so on. So this is the formula which required to find. Certain hello. Fena difference am plus no. Zanchon roshto. Factor ke dosto. The factor tandozi usar bin ken. One yagek element ke dosto zanchon ke bosia ya. Leader ke boy ke out the scale. Okay. Here we have an application example. This a depositor deposits 10,000 ringgit Malaysia. I just say RM, okay? In a saving account at a bank yielding 5% per year, with the interest compounded annually. Ale? Qu'est-ce que paraît dans le banque? Régime le sa pinge et chute de cesse. Régime le sa pinge et chute de paraquet. Salan. Chani here. La sa pinge et chute. Okay? So how much money will be in the account after 30 years? That means here we should find A30 in the sequence. Okay, so what's the initial one? It's 10,000. Okay, the A naught is 10,000. And it's increased by 0.5 of the total money per year. Okay, and here we say Pn equals Pn minus 1 plus 0.05 of the total money. So 5% means 5 over 100, which is 0.05. So the money is increased by 0.05 of the total money. That means here we use P for the sequence. Pn equals Pn minus 1 plus 0.05 times Pn minus. پارەکەی خۆی گریمە 1000 دینار لە شوێن دانا ملیۆنێ دانێ باشە ساڵانە لە سای 5 جێسەر پارەکەی خۆت هەرە مێنێ لە بانکە لە ئەکاونتەکە لە سای 5 جێسەر. Okay, that means the money then the interest one. This is the interest. Okay, so it's Pn minus 1 plus 0.05 Pn minus 1. We say if you have, let's say, x plus 0.05x, it equals to what? 1.05x, is it? It's the same. If you have P1 plus 0.05 P1, that means Pn equals 1.05 Pn minus 1. This is Pn. Okay. How about after 30 years? After 30 years, that means A30. What's A30? We should find A30. Okay. We say Pn is the current balance and Pn minus 1 is the previous year balance, and 0.5 is the compounding interest. To solve this, P0 is given with 10,000s. P1 is 1.05 times P0. Is it? It's 1.05 times P0. How about P2? P2 is 1.05 times P1. So what's P1? P1 is 1.05 times P0. We replace, if you replace P1 by 1.05 times P0, we get 1.05 times 1.05 P0. This is P2. This is P1. We say P2 is 1.05 P1, but P1 is 1.05 P0. Is it? So now we say 1.05 times 1.05 is 1.05 squared P0. We are going to write down the general form of the sequence regarding the P0. How about P2? P3. P3 is 1.05 P2, but we found P2. P2 is 1.05 squared P0. We replace this by 1.05 squared P0. It is 1.05. This is that 1.05, and here you have 1.05 squared P0. It equals 1.05 cubed P0. Here when we say x times x, it equals x squared. How about x times x squared? It equals x cubed. Is it? Here, x denotes the 1.05. لێرە چیەکەین ئێمە ئەوەی کە پێمان دراوە لە پرسیارەکە پینۆتە پینۆتمان پێ دراوە و ئەژلێ بە ڕێژەی لە سا پێنجیاکات ساڵانە کەواتە ئێمە ئەوە ئەزانین Pn is 1.05 Pn minus 1. We know that. We found that before. Okay? So here, how about P1? P0 is given with 10,000s. How about P1? We say P1 equals 1.05 P0. How about P2? How about P2? P2 equals 1.05 P1. But you found P1 before. P1 is this. If you replace P1 by 1.05 P0, what we get? We get 1.05 times 1.05 P0. This is P1. We just replaced it. by its value. So here we get 1.05 times 1.05 is 1.05 squared. That means here P2 equals 1.05 squared times P naught. Here we get P naught. And then for P3 equals, regarding to this formula, P3 is 1.05 P2. What's P2? P2 is 1.05 squared P naught. ليه أو هيش P يعني عندي P naught. هم بالنسبة P naught on this, okay? P naught mandra P1 كاتشي 1.05 P1 P naught. P2 كاتشي 1.05 P1. طبعا P1 مان هي P1 شنو 1.05 P naught. 1.05 times 1.05 1.05 squared. And here we say 1.05 P2. What's P2? It's 1.05 squared P naught. We just replace it by the value. We get 1.05. This one is that. And what else do we have? We have P2. For P2, we have 1.05 squared P naught. We get 1.05 squared P naught. We have, let's say it's x. That's x squared. So what we get in multiplication? We get x cubed. So x is 1.05. That means P3 is 1.05 cubed P naught. And so this cubed. So how about how about the fourth term? For the fourth term, we say P4 is 1.05 to the power 4 P naught. P5 equals 1.05 to the power 5 P naught. How about P30 equals 1.05 to the power 30 P naught. We should find P30. So P30, that's here. P30 is 1.05 to the power 30 times P naught. P naught is 10,000. Multiplying these, so you get 43,219.42. This is after 10 years. So the money from 10,000 become 43,219.42 RM. It's after 10 years, after 30 years, sorry. If someone puts 10,000 in a bank with the interest, with the compound interest of 5% annually, after 30 years, the money becomes 43,219.42. And it's enough for today.